In this next problem, we have a rock that's being released from the top of a 30-meter high cliff. So that's at position A. We have a rock there, and that rock's being dropped. And at the same time, we have a ball that's being thrown upwards from the base of the cliff at 20 meters per second. So at the same time, we have a ball at the base of the cliff, and that red ball is being thrown up into the air at 20 meters per second. And this question is asking for how much time passes before the two rocks collide. Okay, so let's take a look at this particular problem here. If I'm looking at my blue rock, which starts at the top of this 30-meter cliff here, clearly from A to B, the rock is falling down. So what we're going to do is, for the rock that's being thrown down, we're going to collect some information here. So when we're falling down, your initial speed is going to be 0 meters per second. And since the ball is falling down, your acceleration due to gravity is going to be 9.80 meters per second squared. Okay, the next thing I want to do is I want to come up with an expression for the distance traveled by the ball from A to B. And in order to do that, I'm going to create a new variable here. So if I look at the situation from C to B where the ball is being thrown up into the air, let's just call this distance here x. All right, so I don't know how far the ball goes up into the air. So if that distance is x, then the distance that the ball that starts from the 30-meter cliff that's being dropped from that height, from a height of 30, this new height is going to be 30 minus x. Okay, so hopefully that makes sense here. So let me kind of write 30 minus x for my distance in meters. So what I'm just trying to say here is if the ball from the base of the cliff is being thrown up, let's just say it travels x meters up into the air. And since the entire cliff is 30 meters, that means this distance over here in blue has to be 30 minus the x. So the distance traveled from the ball from A to B going downwards travels 30 minus x meters. Now, based on this information right here, I want to find a kinematics equation that relates the initial speed, the acceleration due to gravity, and the distance traveled by the ball from A to B. And one formula that is going to look very good for this particular case is the distance equals to the initial speed times the time plus 1/2 at squared. Okay, so we know the distance here. It's going to be that distance there. So this is going to be 30 minus x equals to your initial speed, which is going to be 0 times the t plus 1/2 times 9.80 times t squared. Okay, so based on that, we still have the 30 minus the x on the left-hand side, and on the right-hand side, I have 1/2 bracket 9.80 bracket and then t to the power 2. All right, so I'm going to hang on to that this expression right here because this will come into play in the next part of this question here when we look at the ball when the ball is going from C to B now. Okay, so if I look at the situation where the ball is going in the upwards direction, let me erase that. Okay, so if I take a look at the situation where the ball is going from C to B in the upwards direction here, well, the ball is being thrown up into the air. So the ball is being thrown up into the air. Its initial speed is going to be 20 meters per second. So my initial speed is going to be 20 meters per second. And since the ball is being thrown up into the air, I like to label the acceleration due to gravity as negative 9.80 meters per second squared. And also I want to find the distance traveled by the ball going up from C to B. And we've noticed that we've already denoted that the distance going up is going to be labeled x. Okay, so that's the distance being traveled in the upwards direction from C to B. Now, based on this information here, I want to find another kinematics equation that relates all this information together, your initial speed, acceleration due to gravity, and the distance traveled. And I'm going to use the same equation from the previous previous section, which is distance is your initial speed times your time plus 1/2 at squared. Okay, so the distance traveled by this ball when it's going the upwards direction is going to be x equals to your initial speed, which is 20 times the time plus 1/2 a, which is negative 9.80 times t squared. Okay, so I'm going to put that in a purple box right there. All right, so now the key to this question here is we've got two equations right here that I've highlighted in purple there. And what we're going to do is, since over here, x has been isolated. We're going to isolate for x over here on the left-hand side there. So if I isolate for x over there, I get 30 over here equals to, 30, and then, minus, and then we're going to bring all of this to the left-hand side. So this part here in blue, we're going to bring that to the left-hand side as a 1/2, negative 1/2, bracket 9.80 t squared, and that's going to equal to the x variable on the right-hand side. So this x just moves over there. Okay, and now after that, we can just make these two variables equal to each other, since they're both equal to x, and then we can solve for the time. Okay, so if I do that, we have 30 minus the 1/2 bracket 9.80 bracket t squared equals to all of this, which is going to be 20t minus the 1/2 bracket 9.80 bracket t squared. Okay, so let's take a look at this expression right here, and let's just see what we can do here. Okay, so one thing I noticed right away is this whole expression right here in blue, that's negative. And if I look at this expression over here, it's also negative. If I bring this blue expression over to the left-hand side, it turns out that these two terms just cancel each other out. So now we're left with 30 on the left-hand side. And now we're left with 20t on the right-hand side. And if I solve for time here, it's simply going to be 30 divided by 20, and that's going to be approximately 1.5 seconds equals to my time. Okay, so there's my time there, 1.5 seconds. All right, so what does that mean? If I go back to my diagram here, if I just erase all the colors here, so I guess it's going to take 1.5 seconds for the ball from A to B to collide with the ball from C to B. So from C to B, a ball is being thrown up into the air, and then from A to B is actually a rock that's being dropped from the height of 30, and it takes 1.5 seconds for those two objects to collide. And that's it for that particular problem. Let's take a look at this next problem here. And for this next problem, I have a projectile that's being launched towards the wall as shown in this diagram below. And for this problem, we want to find its velocity, magnitude, and the direction when it hits the wall. So if this projectile starts at position A, eventually it gets to a maximum height at position B, then it hits the wall at position C. When you're at C, you have a horizontal velocity component and a vertical velocity component. And then the velocity that we want is this purple vector right here. This is the magnitude, and we'll call this the velocity of the wall. All right, so that's the velocity that hits the wall with. And since that's this magnitude, we want to find this direction, which is right about there, that angle right there. So that will tell us that will satisfy the conditions for this problem, the magnitude and the direction. Okay, so for this particular problem, I noticed that the ball is being thrown up into the air from A to B, so it's going the upwards direction. So we also have this angle right here, so therefore we can also find its vertical velocity component and its horizontal velocity component, Vx and Vy. So let's go ahead and find Vx and Vy right away. So your Vx component right here is going to be the 25 meters per second, and that's going to be at cos of 35 degrees. And if we calculate that on a calculator here, we get 20.478 meters per second. And for my Vy, my velocity, my vertical velocity component, that's going to be the initial speed of 25 meters per second, but that's at sine of the angle, so sine of 35. And that gives me a vertical velocity component of 14.339 meters per second. Okay, so we're going to be using those two numbers there to kind of help us out in this particular problem here. So if I look at this particular case from A to B while I'm going up, its initial speed, which is equal to my vertical velocity component, that's going to be 14.339 meters per second. And since this ball is going up, its acceleration due to gravity is going to be negative 9.80 meters per second squared. And once I'm at position B, which is the max height, that means my final speed there is going to be 0. And what I can do there is I can actually find the time it takes for this projectile to go from A to B, which is the maximum height of this projectile there. Okay, so based on that information right there, the kinematics equation that I want to use is my final speed equals to my initial speed plus my acceleration times time. Okay, so that's the kinematics equation that I want to use right there. So my final speed is going to be 0. My initial speed is going to be 14.339 plus acceleration due to gravity is going to be negative 9.80 times my time. Okay, so if I kind of manipulate this formula here, my time that I need is going to be, let's say this is going to be 14.339, and I'll divide that by 9.80, and that'll give me a positive value for my time going in the upwards direction there. So the time it takes is going to be 1.463 seconds. Okay, so what that means now is if I want to go from A to B, the time it takes to get to from A to B is going to be 1.463 seconds. So that's basically what I found right there. And what I'm going to do next here is we're given the range of this projectile, right? This range is actually 40 meters. And with that 40 meters, I can actually find the total time that this projectile is in the air. And I will definitely need that because I want to find the time it takes from B to C. Okay, so if I can find the total amount of time it takes to go from A to C, I can subtract that from the total time from A to B, and then I'll have the time it takes from B to C right there, right? Okay, so let's go ahead and use this range right here, which is 40 meters, and let's just see if I can find the total time that this projectile is up in the air. Okay, so in order to do that, what I'm going to write down is I'm going to write down range is equal to your horizontal velocity component times the time. So I know that my range is 40, and Vx is what we actually calculated at the start of this problem. Vx is going to be 20.478 meters per second. So this is going to be 20.478. I'll put that in brackets and I'll put a time there. So then my time is really equal to 40 divided by 20.478, and that's going to equal to a total time of 1.953 seconds. Okay, so that's going to be a very important time to know. And basically what I'm going to do with this 1.953 seconds is that I'm going to go back to my diagram here. Okay, so let me just kind of erase some of all this. Get rid of all these colors here. Okay, so let me just erase all this. Okay, so what we're saying is the total time that it takes to go from A to C, that was 1.953 seconds. And we know the time it takes from A to B, that's what we found in the previous question, that was 1.463 seconds. Therefore, we can definitely find the time from B to C, right? From B to C. So it's going to be 1.953 seconds, subtract from 1.463 seconds, and if we do that, we get 0.490 seconds. Okay, so the time it takes to go from B to C is 0.490 seconds. Okay, so now let's collect some information from B to C. If we start collecting information on the projectile from B to C, which means we're going in the downwards direction, so that means your initial speed is going to be 0 meters per second to start. Your acceleration due to gravity, since you're falling down, is going to be 9.80 meters per second squared. We know that time it takes for this ball to hit the ground from B to C is going to be 0.490 seconds, and what we need to find is your final velocity. Okay, so there's my final velocity right there. So what we need right now is we need the kinematics equation that relates initial speed, your acceleration due to gravity, and your time, and we want to find your final speed there. So the kinematics equation that we need is your final speed is equal to your initial speed plus your acceleration times time. Okay, so your final speed is going to be Vf. Your initial speed is going to be 0 plus 9.80 times the time of 0.490, and it turns out that your final speed for this particular problem is going to be 4.802 meters per second. Okay, so let's go ahead and put this information all together now, and let's just see if we can find out what the velocity that the projectile hits the wall with. Okay, so let's go back to this diagram here. Let me erase all this. Let me erase all that. Okay, so once the ball hits the wall right here at position C, it has a horizontal velocity vector, which is Vx, and it also has a vertical velocity vector, Vy. Okay, it turns out that the Vy is actually this number right here, 4.802 meters per second. So if I just redraw the Vy down here, that's going to be 4.802 meters per second. And we know that the Vx, we actually found the Vx right from the start of the problem here. Vx is going to be it's going to be this number right here, which is 20.478. Okay, and with that, we can now find the velocity vector right there using the Pythagorean theorem. So this is the V wall right here. We can find V wall by using the Pythagorean theorem here, right? So we'll say V wall, that's all being raised to the power 2, and that's going to equal to the horizontal velocity vector, which is 20.478 squared, plus 4.802 squared. Okay, and I'm not going to go through all the steps here, but if I go ahead and square them and add them and square root the final answer here, the velocity component here is going to be 21.033 meters per second. And if I want to find the angle right here, which is theta right there, we want to use tan of the angle. So if I use tan of theta, okay, so just remember, tan of theta is your opposite over your adjacent, right? So this is your opposite, and this is your adjacent. Okay, so your opposite is going to be 4.802 divided by 20.478. And if we find our angle here, basically you go to your calculator now and do the inverse tan of 4.802 divided by 20.478. If we do that, we get roughly 13.199 degrees, and this is below the horizontal right here. All right, so that right there is your direction, and your magnitude is right here, around 21.033 meters per second, and the direction is 13.199 degrees below the horizontal. So that takes care of the magnitude and the direction right there. Okay, so that concludes this homework help video.